Hello, so you had a question on these section 8.1 problems. I wasn't sure which problem you were referring to in your notes, but I noticed one that was marked wrong on your problem set. And so I'm going to just go through and do it for you, and hopefully that will help you to see what's going on. Okay, so it says a simple random sample of size n equals 64 is obtained from a population that is skewed right with a mean of 81 and a standard deviation of 24. Okay, so the population, we had a mean of 81, I believe, and a standard deviation of 24. That means that we had a distribution, or x is whatever the scenario is, like these are like the individual measurements. And we have our mean at 81, and then a standard deviation above and below, 24 above that, so that's going to be 105, 478, and that's 58, I believe. Okay, so that's what it is. Then we went through and we took a sample of size 64, and then we found the mean of that sample. Okay, so coming back here, coming back here, we are now going to have a distribution, because if we took a different sample of 64, we would probably get a different sample mean. So there's going to be a sampling distribution for this sample mean x bar. Okay, so the sampling distribution, sorry, it's going crazy. It's because I'm not in my normal workspace. Sorry. Okay, so we have a distribution of samples, means. Okay, so now we have a new distribution. Okay, the problem it said that this was skewed right. I think it said skewed right. It said skewed. So I shouldn't have drawn it as a distribution, as a normal distribution like this. But it's skewed, but because my n is greater than 30, so the sampling distribution is going to be normal. Since my population distribution was not normal, I had to have greater than 30 in my sample for that to be more normal. Okay? And then we're going to get a distribution of sample means. So it's going to be a sample mean of 64 individuals, whatever the individual is. Okay, so my mean of my sample means is going to be the mean of the population, which was 81. I'm sure I had that number right. Yep, good. Okay, the standard deviation of the sample mean, it's going to be the standard deviation of the population divided by the square root of n. It's also called the standard error. So it's going to be, in this case, it was 24 divided by the square root of 64, which is 24 divided by 8, which is 3. So now we have a new distribution that has a mean of 81. The standard deviation is going to be, standard deviation of the sample mean is going to be, because of the sample means that we're measuring here, is going to be 3. Okay, so you can see this is going to be a much more compressed distribution, because one standard deviation is a lot smaller, because when you average things out, the extreme values become less influential. Okay, so the first thing, which you got right, says what the probability that the sample mean is greater than 86.85. Okay, so 86.85 is going to be, first I want to find the probability that my x bar is greater than 86.85. Okay, so 86.85, it's going to be 87. It's going to be like basically right there, and I want to know all the values greater than that. So it's going to be a small area. You're going to go and go to normal CDF. And the lower value of this region is going to be 86.85. The upper region is going to be infinity, because it keeps on going forever. We don't have infinity on our calculator, but we're going to show you what to do with that. Your mean is 81, and then your standard deviation is going to be your 3. Okay, so I'm going to try to show it to you in this smaller region. So I have, you go to normal CDF, and I have 86.85. My upper bound is infinity. I don't have infinity on my bound, so I'm going to have 1 times 10 to the 99th, which is 1 with a 99 zeros, which is a pretty darn big number. In my mind, basically the same thing as 0. Okay? Infinity, basically the same thing as infinity. So then I have 81 as my mean, and my standard deviation is this one, because we're looking at the sample mean distribution. When you come down here and we paste it, you push enter, and you get 0.0256. Which you got right. Okay? The next problem asks for the probability that x bar is less than or equal to 74.7. So again, you have your distribution. Measuring x bar, we have a mean of 81. Sigma of x bar was 3, remember? So we have, this is going to be 78. That one's going to be 75. So right below that is 74.7, and it's going to be that area. Okay? So I'll have a normal CDF, negative infinity, 74.7, 81, and 3. So I'm going to have my negative infinity, so I'm going to have a negative 1 times 10 to the 99th. My upper bound is going to be my 74.7. Mean is standard deviation are those. Push enter, and I get 0.0179. Okay, and this last problem is the one that you were really concerned about. Probability that we are between, our sample means between 76.95 and 86.55. So the probability that my sample mean is between, I don't know what I said, 76.95 and 86.55. Okay. So again, we draw our distribution. We're looking at the distribution of x bar, so we have to use that information. So we have 81, 78, 75, 72, 84, 87, 90. And so when you draw a distribution like this, the empirical rule is still going to work out. There's going to be about 68% between one standard deviation. It's going to be about 95% between two standard deviations above and below, etc. So using that in mind, we have 76.95, which is like, I don't know, like there. And 86.55, which is like there. And it's a little bit, it's more than the 68%, but it is a little bit shy of the 95%. So somewhere between 68 and 95 should be my answer. Okay, so again, we go through and do a normal CDF. My lower bound is 76.95. My upper bound is 86.55. My mean is 81, and my standard deviation is 3. Okay. And just as a note, when you have this one was a really nice standard deviation, but if it was a complicated one, like a decimal, you can just type in the formula in this. So you can have like 76.95 for my lower, 86.55 for my upper, means 81. And if you wanted to, you could have done like 24 divided by the square root of 64. And here it ended up being a really easy answer. But if this was a decimal approximate, you wouldn't have that approximated because you could have write this formula in. Okay. See, it just writes here the formula for you as the input to the other formula. Okay, push enter, and you get 0.8793. And then conceptually, we were like, oh, it's almost 95, but it's short of that. And then it's definitely over 68 because remember, by the empirical rule, 68% is between here and 95% is between there. So it has to be somewhere in between that because my area from here to there is between 68 and 95%. So that should be intuitively make sense. Okay. So you can kind of see here, you got the first two answers correct. You did not get the middle answer correct. I'm not sure what you did to get that, but you can see it's 0.8793, which is what we got as our answer. See? Okay. So hopefully that helps you to understand what is being asked of you, and you can interpret it better. Okay, good luck.